let us differentiate this. You can differentiate this using the power rule, the chain rule, the quotient rule, and the product rule all combined. But there's an easier way to do this, which is using logarithmic functions. So what I'm going to do first is I'm going to say y is equal to 1 plus x cubed 2x minus 1 to the 5th power divided by x minus 3. The reason why I'm doing that is so that I can just say, since what I was going to want to do would have not been easy to do here, but I'll do it here easily. I'll say in log of y. I'll take the in log of the right hand side, and then I'll also take the in log of the left hand side, which would be 1 plus x to the 3rd power 2x minus 1 to the 5th power, all divided by x minus 3 to the 7th power. Now let's focus on this side. We'll get back to this guy. Now we have a division sign here, which means we can apply the law of logs, which says that you can say in log of the top part, which is 1 plus x to the 3rd power 2x minus 1 to the 5th power, and subtract the in log natural log of x minus 3 to the 7th power. Right, since there's division, you can write this in this form. It's a law of logarithms. Now we have a product here. The product can be written as a sum. So we'll do this. We'll say in log of 1 plus x to the 3rd power plus in log of 2x minus 1 to the 5th power, and then this, which is minus in log x minus 3 to the 7th power. Now what we'll do is apply yet another law of logs. We're just manipulating using logs to make the question easier. So here we take the coefficient about the exponent and make it the coefficient, which will be 3 in log of 1 plus x, plus here we do the same thing. We have 5 in log of 2x minus 1. Same thing here. We have minus 7 in log of x minus 3. Right, so now what I want us to do is I want us to find the derivative of both sides. So here we have the derivative of in log of y, because we had in log of y this side, and this side we have the derivative of 3 in log 1 plus x plus 5 right. Now the derivative sign can be distributed, and we'll take out the constants out of the derivative sign. So it'll be 3 d1 dx of ln 1 plus x plus 5 d1 dx ln x minus 1 minus 7 d on dx then x minus 3. Okay, so now it's time to find the derivatives. Here we have 3, and the derivative of ln 1 plus x. If you want to find that, there's a video that I teach it on, but the simple way to do it is you take this, you make it your denominator, 1 plus x, and then you find the derivative of this, it's 1, you put it there. Done. Plus 5, we get to this one, we do the same thing. You take this, x minus 1, you make it your denominator, and the derivative of this, wait, this should be 2x. Derivative of this is 2, you put it right there. And then you have minus 7, same thing again, you take this, you make it your denominator, minus 3. Derivative of this is 1, that's your numerator. Right. This is how we are, where we are so far. Let's try to simplify it. It's 3 divided by 1 plus x plus 10 divided by x minus 1 minus 7 divided by x minus 3. Right, so what I'll do now is take the LCD. The LCD will be x plus 1, x minus 1, x minus 3. And at the top, we'll have 3 into x minus 1, x minus 3, plus 10 into x plus 1, x minus 3, minus 7 into, wait, something was supposed to be 2x. So many mistakes. Okay, so this is 2x minus 1. This multiplied by x plus 1, 2x minus 1. Okay, so because I want to get to the answer real quick and I don't want to focus too much on simplification, I'm just gonna do I'm gonna do something here. This side we have the derivative of ln y, right? For the derivative of ln y, how we find that is we do the same thing we did here. We said we put the function as itself on the denominator, and then we put the derivative of the inside function as your numerator, because we said the derivative of this is here, so we say y prime right inside there. So y prime is basically d on dx. It's just that it'll take like a lot of space, that's why I'm doing it like this. So let's multiply both sides by y so that we don't have a y here anymore. So that would mean we have y prime as y into this entire thing. Now let us try to do a bit of simplification. We have 3 into, this is 2 times 2 to x squared minus 6x minus x plus 3 plus here it will be 10 into x squared minus 2x minus 3. There will be minus 7 into 2x squared minus x plus x minus 1, all divided by x plus 1, 2x minus 1, x minus 3, close the bracket. I said y prime is actually dy on dx, which is what we're looking for. So we also know what y is, because y is equivalent to this. So we'll take this and write it in the place of y, not d1 dy, but rather y. So you could also write it here, and then, but here this is the important part, where you're supposed to say y 1 plus x all to the third power, 2x minus 1 all to the fifth power, divided by x minus 3 all to the seventh power. This is multiplied by this huge fraction, which I'll try to simplify. This will give us 6x squared. This is 10x squared. This is minus 14x squared. This is 16x squared. If you minus 14x squared from that, you have 2x squared. Negative, or 16 and 14 here have 2x squared. Right, this is minus 7 times 2, that will be minus 4 times 3, that will be 21x. Here we'll have 20x, but it'll be negative, and this one will also be negative, and therefore we'll have 41x. Here we'll have minus 7x, which means you have negative 48x. Three times 3 is 9. This is negative 30. 30 minus 9 is 21, but it will be negative. Negative 21 plus 7 is 28. Oh, wait, what? Negative 21 plus 7 is actually negative, okay, 20 minus 7 is actually just 14. Now we have x plus 1, 2x minus 1, x minus 3. dy on dx is, now we have x plus 1 here, which will cancel 1x plus 1 here and have squared. And it was 2x minus 1, so this will be 4. This will combine, so here we just have this guy, 1 plus x squared, 2x minus 1 to the 4th power, multiplied by this guy, which is 2x squared minus 48x minus 14. Probably factorizable, but maybe not. And then we have x minus 3. Here the exponent will add, so it'll be 8. You can further on try to simplify this, but I think this is as far as necessary right now. Thank you.